So yes, hello everyone, good afternoon. My name is Chris, and because I love functional programming, I will be talking about MVC pattern, because obviously those two things works well together. My name is Chris, I'm from Poland. Usually when I talk about myself, I call myself open source maintainer, maybe open source contributor. But yesterday, Philip Carter, who just did talk on this stage, called me OSS troublemaker, and I really like it, and it sounds nice. So let's go with that. For those of you who don't know me, I'm like active member of F# community. I'm maintaining Ionite plugin, which also Philip has mentioned in his talk, which is set of plugins for Visual Studio Code that gives you IDE-like experience in Visual Studio Code. It's really good. I'm also maintainer of a couple of other smaller projects. And recently I've created new project that I will be talking about. It's called Saturn, but we will get to this point later. Yes, before we go any forward, this is a controversial topic. Just because there's a couple of different web frameworks and web libraries in F# web space, and people are really opinionated about how stuff should look like. So yes, it's this talk, and Saturn in general is my personal vision on how web programming can look like with F#. And warning number 2 is I don't know enough about WebSharper, so I just won't be talking about WebSharper. WebSharper is really cool project, from what I understand, that enables you to run code both in server and in front end. It's really nice. It's one of the solutions that enables you to do that with F#. It's pretty old project with commercial support, so feel free to check it out. And there is one main reason why I'm actually doing this talk, and there is one main reason why I'm interested in web programming with F# in general. Web in principle is functional. Especially HTTP protocol. HTTP protocol can be modeled as a function that takes HTTP request and returns HTTP response. And that's all. This is plain function. It may have some side effects, it may not have any side effects, but in the end, we send request, we get back response from the server. So if this is just a function, you could think that functional programming language should work pretty well with this model. F# is functional programming language. We are in functional programming track here. So yeah, let's talk about that. And for a couple of years, there have been few libraries that focus on web programming with F#. And the main one for a while was Suave. And then Giraffe is basically implementation of same programming model that Suave do on top of ASP.NET Core to enable us to do really cool stuff and integration with ASP.NET Core and get all these amazing performance benefits that ASP.NET Core team is so proud of, which is really cool. Before going any further, actually this I've lied to you. This HTTP request returning HTTP response is not really everything that server needs to know. That was point of view of like external client, like JavaScript library that calls just some code and waits to get back some response. But from server point of view, we need something else, and this something we need something more, and this is usually called HTTP context. It's called a bit different in different libraries. Let's not focus on that. Let's call it HTTP context. And HTTP context contains a couple of informations, not only just HTTP request. So it contains HTTP request, but it contains also current state of HTTP response. And it contains any additional information about, for example, server, any global state if you have any. So, yes, we model it right like that. And the second important concept is the thing called web part. Web part is the name taken from Suave. In Giraffe, it's called HTTP handler. In Giraffe, it's a bit more complex than that. But in principle, web part is a function that takes context And may, so we have this option type. So it may result new HTTP context or may not result new HTTP context. And in principle, it's async operation. It may take a while, so it's pretty obvious to make it async operation, especially on .NET. We can have multi-threading, so making stuff running as an async makes sense. Yes, and for those of you who has been on Scott's Vlashin talk today morning, Scott's in the end of his talk, he actually used Swav as an example of function composition. And we have two main ways of composing web parts together. First one is this funky operator. It's a rocket operator. And functional programmers usually call it bind. Well, it's not actually a bind, but let's not go too deep into that. It takes two different web parts and produces one web part out of those two. So what it does, it takes HTTP context, it evaluates first web part. If first web part returned some, so it returned result, it pushes this result of the first web part into second web part. If it failed, it just returns none. So this is the example of this power of composition that Scott was talking in the morning about. So that's the first operation. And second one is choose combinator. And choose combinator takes list of web parts, also returns single web part. And it basically checks different web parts one by one from top. So we go to choose, we have list, we go to first element of list, we check if route is ping. If it is, we return pong. If the route returns none, because its route is not ping, then we go to second, and we check if route is nothing. And we can have many of those cases. What's super nice about that is the fact that it works well together. So both rocket operator and choose returns web part. So we can compose, again, result of one binding one choose with other web parts. So we can create those pretty complex applications with this composition that functional programming is all about. And if you squeeze a bit and look at that, it kind of creates decision tree of what's going on in your application. It's not decision tree per se, but we check, we go to web part, we check if it's get. If it's get, then we make another decision. If it's not get, we go to post, we check if it's post. If it's post, we make some other decisions, and so on, so on, so on. So this is really nice model. And again, the warning, don't get me wrong, this model is really good. I've been using Swav for years with F# in both open source and commercial product. I've been using Giraffe for the last couple of months in both open source and commercial products. And this is really nice model. The power of this model is, first of all, it's super simple. So you literally need to know those two operations. So rocket operator and choose function to create any possible decision tree you want to do in your application. Secondly, this model is really powerful and it's really flexible because you can, using those operations, you can do whatever you want. You can model anything that's correct according to HTTP protocol. And even you can do stuff that's not really related with HTTP protocol. But the model, and yeah, before going to some problems. I've seen people that have done nothing with web programming were able to learn this model in 1 week and be productive with it and create applications that right now are running on for millions of users. Well, maybe hundreds of thousands of users. So this is really good. But the model has a couple of problems. And this is my opinionated stuff. So for me, it doesn't scale well with size of the application. So yes, you can compose, you can create names for parts of your application and then compose it using names, because yes, functions are first-class citizen in F#, so you can pass them around. But for me, it's not really there. Like if you have big application with 40 controllers, like REST controllers, which has like every REST controller have like 6 endpoints for different verbs in HTTP protocol, and different like endpoints with ID or not ID. This is growing massively, and I mean it's growing massively. And I've seen such code bases, and such code bases are not really nice to work with. It's pretty low level. So yes, it's really powerful, it's really flexible, but it means it doesn't really provide those, like, it doesn't have batteries included. You need to build everything on your own step by step. If you return JSON from your API, you need to remember to set content type to application/JSON. If you get request, you need to manually check if it's content type JSON, if it's content type XML, or whether it's something different, and you must manually encode this logic. And usually we are familiar with web frameworks like ASP.NET, like Ruby on Rails, like Phoenix in case of Elixir, and they are solving this problem for us. So yeah. And last thing is it doesn't provide structure, or maybe to say it a bit differently, it doesn't provide you a bit of success. Mark Seaman is doing great talks about functional architecture, and he's always saying about this bit of success concept, when language features or language architecture that's pushed into you by the language causes you to make good architecture automatically. So you don't need to work hard to make things well. You just follow the path of least, the easiest path, and you will end up with good architecture. Swath and this model doesn't provide you that, because you can combine it however you want. You can do some crazy stuff, and because of that, it's error prone, because you can accidentally may do some wrong composition and do check that takes really long time, or some operation that takes really long time, and accidentally plug it on top of your application, and it will be run for every endpoint. Instead, maybe it should be run only for one endpoint. And there is nothing that will stop you to doing anything crazy like that. And it's easy to make such mistakes, especially if you're new to technology, you don't have a lot of experience with the technology. And also, it doesn't provide really any patterns related to how to structure code, how to structure your project, how to structure your solution. And if you think about that, those patterns are actually important, because what you want to do as a software developer is you don't want to focus on modeling your web server correctly. You don't want to focus on modeling HTTP server correctly. You don't want to focus on thinking about how to structure code. You just want to write business code and earn money for your company as a result of writing business code, or lose money for your company, depending on what you want to do. So, on the other hand, especially in object-oriented programming languages, we have this thing called MVC pattern, and it's really, really popular, really successful. ASP.NET MVC, Ruby on Rails, Django, well, it's not MVC per se, but it's similar. So, in MVC pattern, we have model, which is represented by some classes. We have view, which more classes. And then we obviously have controller, as name suggests, classes again. And probably you're right now thinking, hey, Chris, you're on functional programming track. We don't want to hear about classes. Yes, but this model, this pattern has a couple of advantages. It's usually high-level model. So you create controller, and controller handles for you routing. You just create some, maybe put attribute if you want to modify something, but usually all those frameworks has some kind of conventions that work out of the box, and you just write your business domain code. They provide structure, so you know that you need to put views into view folder or whatever. This is a bit silly, but they do. And this enables them to provide great tooling around them. So it enables developers to create scaffolding tooling that you do right-click in Visual Studio, create new controller, and this controller will, this thingy will not create only controller, but it will also like create entity framework context for you and connection to database and everything and some default views, and everything will work out of the box magically. And I know that maybe it's not super popular, but I actually think it's a good thing because it enables new people to learn framework really fast because they don't need to think about those details. It enables you to be really productive. Those frameworks has usually one big drawback, so there is no easy way to fall back to lower level. Usually there is a way, but usually it's really like tricky. So you need to override some classes or implement some magical interface and plug it somewhere in the startup with ASP.NET, for example. And no one but ASP.NET team knows exactly how it works. So the question is, can we do better than any of those scenarios? And I guess the answer is obviously yes, because otherwise I wouldn't be standing here in front of you. Let's imagine a perfect world in which we have, again, MVC pattern, but our model is not some random classes with some mutable state, but it's immutable model and pure functions that operates on them. That's pretty standard, like for functional programming. This is nothing really amazing. View is a function that takes model and maybe some additional context and returns HTML. This should be like pure function without any side effects, just return HTML as a string or any other representation that's working in context of your application. And then a controller may be just a function that takes a set of pure functions and wrap them together in opinionated way using some kind of convention, just like MVC frameworks usually do. And here we come to my project called Saturn. Saturn is how I describe this. It's opinionated framework built on top of Giraffe and ASP.NET Core that implements MVC pattern in functional programming way, which is a lot of buzzwords. But first of all, it's implemented on top of Giraffe. Giraffe is implemented on top of ASP.NET Core. This means that we have access to this huge ecosystem of ASP.NET Core libraries, ASP.NET Core extensions, not only from Microsoft, but also from huge C# community, which is really, really important. And it's not really a case with Swav, for example, when basically Swav lives in its own ecosystem. Yes, it integrates with existing ecosystem. Saturn, one of the aims of the Saturn is also provide additional tooling. So if anyone of you follows me on Twitter, you may know that I have this like developer experience and tooling fascination. And I've been, for the last couple of years, I've been doing a lot of stuff in this space, a lot of open source stuff. And I really, really think that having good developer tools is really important part of the success of some of those frameworks. It's not only about API design, it's not only about code quality, it's not only about performance, but it's in huge part it's about how easy you can start with the framework and how easy junior developer will be able to join your team and be productive in context of your team and your application. In principle, Saturn provides higher level abstractions on top of Giraffe model. So instead of using those binds and choose manually to compose applications, we have a couple of higher level building blocks that will enable you to just write your business, again, business domain, not focusing on this stuff that, in my opinion, should be handled automatically by you. What's really nice about that is I've written here that those are higher level abstractions, but usually if we talk about higher level abstractions in in programming languages, we think about, oh, some class, some additional class on top of other class, or something else. But actually, I'm using one of the features of F# that's pretty unique, called computation expressions. And I'm using really not really well-known feature of this computation expressions to compile them down during application startup, or maybe during even compilation time, rather, to those low-level building blocks. So I will show you in a moment a couple of those abstractions, and all those abstractions are actually compiled down to the web parts, or to the HTTP handlers, how it's called in Giraffe. Which means that you can easily take something I call controller, it automatically compiles down to normal HTTP handler, and you can easily plug it with your lower level Giraffe application, existing Giraffe application with bind function or with choose function, and nothing stops you from that. So this is really powerful model because, and also other way around, all my abstractions enables you to plug existing HTTP handlers or plug those lower level Giraffe type HTTP handlers, web parts. So it actually we operate on the same abstraction level, but we have higher level building blocks. This may not make a lot of sense, but that's how I like to describe it. So this is pretty unique because you don't need to do anything special to fall back to lower level like you need to do in ASP.NET Core, in Ruby on Rails. You just go back to writing Giraffe code. And if you want to do higher level stuff, you go to writing Saturn code, and it integrates without any problems. It also hides ugly parts of Giraffe. And don't get me wrong, like Giraffe is an amazing library. I love it. What I don't love about it is that it's, well, what I both love and hate about Giraffe is that it sits on top of ASP.NET Core. And ASP.NET Core is amazing technology, but it has a couple of problems, especially if you use it from F#. So ASP.NET Core has been clearly designed with C# in mind, especially stuff like configuration and all those dependency injection that's built in ASP.NET Core, that you need to register some services to enable some features like caching or like distributed caching with Redis or CORS support or CSRF support. All this stuff, it's pretty ugly. And it's not ugly because of Giraffe per se, but it's ugly because of ASP.NET Core. It's not really, this is not idiomatic F# code, and Giraffe was not designed, ASP.NET Core was not designed with F# in mind, and Giraffe does nothing to hide it because that's their philosophy. Yes, and what's next? What's next? I'll go to some demos. And those will be some fun demos, I hope. And we need to pray to demos gods to not kill my machine. One thing I want to tell you, has too many active, that's not important. No one cares. There's one thing before going to demos, actually, I want to mention is, if you were on the previous talk, Philip has mentioned this ubiquitous featureful tooling that F# has across all platforms. And kind of to show that, I'm using Linux with Visual Studio Code. So let's hope that it works. OK, so first thing we've introduced in, and well, let's go back to project file. Project file for Saturn is super simple. You just create console application with .NET Core or full .NET Framework. You add Saturn package reference, and it works. Yes, sure. Thanks. Is that OK? Everyone on the end? Yes? Perfect. So this is normal console application. You open system, which apparently, my editor tells me that it's not necessary. We open Saturn, we open Giraffe. And the first thing is if you haven't seen computation expressions before, computation expression is this block of the code that can have custom behavior. It's actually implemented as a normal class in F#. It's basically just you have some predefined methods you can override to modify behavior of existing keywords, such as let, bank, or return, or do keywords. But you can also create custom keywords in computation expressions. And this is really powerful. This is used, for example, in query computation expression that comes out of the box with F#, I believe, which enables you to write like SQL-like syntax inside of this fancy thingy. And basically what you do is you call computation expression, then you have curly braces, and yes, you have sometimes curly braces in F#. And then the code between curly braces is magical, let's say. So the first thing is this pipeline computation expression. And pipeline is declarative way to compose set of HTTP handlers. This is basically still pretty low level. What it does is actually under the hood, it's using this rocket magical operator. Main reason to do that is actually not really to create this any higher level abstraction, but I have this theory that having those weird operators is not helping adoption of the libraries, so I've decided to hide this under the hood with this nice declarative syntax. Saturn provides set of popular HTTP handlers, such as set header, as custom keywords in this computation expression. This is a bit of implementation details. What's important is that you can just go here, press enter, do set. And there is a couple of things, set body, set status, sign, whatever. There are many of those. And this is nothing really tricky. What's really nice about that is that you can compose, again, as you can see, this is HTTP handler. And HTTP handler, as I've mentioned before, is just web part. It's named differently in Giraffe. But as you can see, it's not really any other new concept. It's not really any other new class, new type that you need to worry about how to compose it together with the other parts of your application. It's normal HTTP handler that you get if you write normal Giraffe application. So this is fun. Because those are HTTP handlers, you can compose them together easily, because you can compose HTTP handlers with other HTTP handlers, and since pipeline compiles down to the HTTP handler, then you can compose pipelines together. Again, we have a couple of those predefined pipelines, but also, and those are those predefined pipelines that are doing something. It's not really important what they do. One is fetching session, second one is changing any head request into get request, because that's what usually people want to do. And the third one is adding some unique request ID to every request you have. It's not really important what they do, actually. It's just showing that you can plug anything, either what we provide out of the box in Saturn, what Giraffe provides out of the box in Giraffe, or custom code you've written like this header pipe. The second concept we have is the thing called scope. Scope is a bit higher level, and scope is used to define routing for your application or subrouting for part of your application. So basically you have keywords like get, post, delete, which can be used to create routing for this part of the application. What's really nice is that it has type-safe formatting. So there is delete F and get F and so on. And here in the root, in the definition of root, you use those %S, %D, %E symbols. And what the framework and what F# is able to do, it knows that S is a string. So it's really nice because you can write your root and it's type safe. That's fun. The third thing, before going to the highest abstraction layer that I want to show you, the third thing we do is we provide application computation expression. And application computation expression is a bit different. Application computation expression actually doesn't compile to HTTP handler because it has totally different reason to be in Saturn. What it does is it hides the nasty configuration that ASP.NET Core has. So as you can see, we just tell it to, every request we want to pipe through endpoint pipe. We tell application which router to use, on which URL we want to host it, and we have something called memory cache, whatever it is. What's nice about it is that it's totally declarative code. I mean, you don't know how under the hood this is enabled, and some of those things are pretty nasty to configure if you don't know what you're doing, and if you're creating new ASP.NET Core application. So let's try to play with that. .NET. Yes, I'm terrible at typing. Let's enable watch mode for that. And it has written something to us that we are actually now listening on the port 8085, application has started. We can go here and yes, there's hello world. That's amazing. And if we go to /a, we get other hello world. So this is a simple thing. It works. But that's probably not you, if you imagine. Like you want those MVC pattern or higher level abstractions. And I have some code to copy paste. Let's copy paste that. The most important part of the Saturn is the controller computation expression. And controller computation expression provides opinionated way to create REST-ish controller in your application. So basically, it provides a set of the actions that you can implement, such as index, add, show, edit, update, delete, create, and I think I've missed one, show. And you just focus on implementing those actions. You just focus on your business logic that's behind those actions. And what controller computation expression does is it puts some predefined opinionated routing about how routing in this controller should look like. And this is following standard REST conventions with some one or two small additions. So get request to the root empty or goes to index. Get request to root ID goes to show, because if you go to if you go to root www.myfantasticapi.com/books/123, you want to see the particular element of the list, not all elements. And so on, so on, so on. That's nice. Let's save the file. This is reloading, this is starting. And I think I forgot about one thing. And this is composable. So you can create new top router that some requests are pointed to the other router that we've defined before. Some requests are pointed out at controller because, we want to have API, we want to have controller. We want to pipe every request through header pipe. We have handlers for not found if there is no route that matches our routing. Yes, and this started. So let's go back here. Now this won't work because we've put it on the API. And controller, what have we done? Users slash. It goes to the index handler. Those handlers are pretty empty. In a moment, I will show more complex sample. But what's important in this sample is that it all actually compiles to those HTTP handlers. So as you can see, this user controller is its type is HTTP handler. It's not anything magic. You can compose it with any other abstraction or any other building block that we've introduced, or with normal building blocks from Giraffe, which is pretty cool, I think. The other thing I've mentioned is that we want to provide this tooling that enables you to quickly start up with your project, that enables junior developers to understand what's going on, that tells you how you should structure your application. And let's close that and go to demo 2. So in current, new, modern .NET world, we have this thing called .NET CLI tool. .NET CLI tool has some templates. So probably we can do something like .NET New to create any application. And let's try to create Saturn. And it actually worked, almost. And ignore that part. I'm using like development version of Saturn. That's why it's not working completely. But it created some application. And let's open it. First thing first, it created solution file. If you like solution files, so you can open it in Visual Studio and Visual Studio for Mac. If you don't like Visual Studio Code for some random reason, you should like Visual Studio Code, trust me. Then it created this thing called packet.dependencies. And if you don't know, Packet is alternative NuGet client that's really popular in F# community. It's really nice. There are a couple of reasons why Packet should be used, but it's out of the scope of this talk, and probably it would take me like another whole talk to explain why Packet is great. But Packet is great, and it's not because I think it's great. Like, I mean, Packet is default choice for most F# projects, most F# open source projects. It also creates build script using Fake. Fake is like build system that provides build definition, and by build definition I don't mean compilation, because compilation is just .NET build, .NET run. This is fairly simple. But what Fake is about creating those complex build processes, such as, oh, I need to restore packages, I need to build, then I need to start application, then I need to run unit tests, then I need to run integration tests, then I need to deploy this to CI server, and then I need to push stuff to NuGet and push stuff to GitHub releases, whatever. So it enables you to script everything, and it has like hundreds of extensions to different products in .NET space, so it has integration for basically everything. Okay. Solution created by .NET New Saturn has 2 projects. One is just named exactly the same as a solution, which is our project with Saturn. The second one is called migrations, and as you can imagine, it will contain some migrations. Let me start the application. Oh yes, restoring packages. Do I have internet? Yes, I do. Good. In the meantime, what we've created, oh, it worked, yeah, amazing. The application we've created already has a couple of files. So it has some opinionated database abstraction that you can use. It's based on Dapper. It's just some nicer F# way of handling some things with Dapper. It has config file, which probably you should, if you have some configuration, you should add it here. For starter, we just have connection string, because that's what we usually have in our web application. We have some connection to database. We have something called templates folder with a couple of templates, which, as you can imagine, describe layouts of your views. It's exactly the same if you would scaffold new ASP.NET Core MVC application. You would have some Razor views out of the box in there, I believe. Or if you would scaffold new Ruby on Rails application. And it has AppFS, which is general layout. It has index view, which is probably your main view of application. It has some generic not found web page. It has some generic internal error web page. It also comes out of the box with router FS file, which defines some basic routing. There is one default pipeline. There is definition of default view, and you probably want to display default view, whether you go to default HTML or index HTML or empty root. Yes, and since it's already started, let's go back here. I cannot fetch. Why I cannot? Because I'm silly. I need to add run parameter. .NET Watch Run started. Yes, and this is like the web page that was created. It's beautiful, right? It's using Bulma, so it's good. It has some links to the documentation, to the GitHub issues, to the Gitter, to places where you can find help. So if you're new to the project, you just want to play with it, you type .NET New Saturn, and you have all this information about where you can go to see it. But that's one part. That's just hello world thing. And just to show maybe some other thing, there is like this custom error page, and you can go back to home page. Like this is something all those frameworks do. But that's just part of the tooling. What we also want to do is we want to maybe create some new controller, new REST endpoint with views and showing up some data. So let's go to source demo 2. Another part of .NET CLI I've mentioned earlier before. .NET CLI enables you to create those extensions to .NET CLI called CLI tools. And it's basically like a custom tool for the project that you can execute in your project using .NET. So we provide this thing called .NET Saturn. .NET Saturn, if you just type it, it has a couple of commands that are possible. Generate the model, access layer, views, or maybe generate just JSON, or maybe generate model, or maybe run migration. It's work in progress in general. Saturn itself is pretty stable, so it's version 0.5, but it's pretty stable in terms of API. It's not 1.0 because I just want to add more stuff to it before going 1.0. But it's pretty stable. There shouldn't be many breaking changes. Tooling is in experimental stage, so it may break, but it's not it's not breaking your code, so I guess it's okay to have some breaking changes. Let's generate something. .NET Saturn gen. Let's generate book controller. Books ID string author. String. And yes, I'm using strings just on purpose because anything else may break. And I've tested strings. Title. String. So basically what I say to the tool is that I want to generate new controller called book, and with fields like ID string, author of type string, and then title of type string. And this is command line tooling, but you can easily imagine that you can have right-click menu in Visual Studio if that's what you like. .NET, well, yeah, typo. Why haven't you told me that I have typo? And there is some output. It generated a couple of files. Books model, books views, book repository, books controller. It updated project file. It created some migration file. It updated project migration. Controller generated. You need to add new controller to one of the routers in router FS. For example, yeah, okay, let's copy paste example. And let's go start the application again. And I forgot one thing. Let's not start application. Starting application was bad thing. The another thing after generating those files, and let's maybe check them out. So it generated books model fs, which is basically plain F# model using record type. It generated some sample, really simple validation file. But at least you know how you should structure your application. Oh, if I want to add more validation to my fields, I need to put them there. That's pretty easy. And you can just go there, write your business code. It generated a couple of views. And again, this is not really important. It generated database repository, something like repository pattern with a couple of queries and actions that can happen with your database. And by default, it's using SQLite. And again, that's because the tooling is super experimental, and SQLite was like easiest to have on your machine. And I can create the SQLite file without thinking about connecting to database and stuff like that. So it's also good for demos. And it created controller. And as I've mentioned, controller actions are just functions. So this is normal function. This is what you would write. It's maybe, well, not necessarily, but it's task. So it's like asynchronous. It's doing some work. So it's getting configuration. It's calling database. And then if database call was successful, then it renders some content. And then it plugs it together in the controller computation expression. In this case, it implements all the actions. If you would call the tool with generate JSON controller, it wouldn't generate the views file, and it wouldn't implement all those actions, but only those that actually follows REST conventions. And before going further, I also need to run migrations. .NET Saturn and this is using the C# library called Simple Migrations under the hood. I don't know how popular this library is, but like I've done some research, and it was like I enjoyed how it works. So it's super simple, and simplicity is the thing I value. So basically, to create migration, you inherit from migration class, and you override two functions. One is what happens if you run migration, and the second function is what happens when you revert this migration. And yes, I've run those migrations in the background, and it's telling me migrating from 0 empty schema to some version, and the version is timestamp when the file was created. So, well, it's this field, but it's timestamp when the tool was run that created this file. Create table. It created the table. It's some not null fields. It doesn't really matter so much. And now I can run application. Okay, so that looks boring, just like before, but we go to this books. Yes, to the books endpoint that I've added. And as you can see, you have some predefined view with listing books. You have button, new book. You can do something. You add, everything is working. It's actually adding to database. So you have this scaffold of application that right now, it may not be perfect. The scaffold is far away from being perfect, but at least you know how to start. You know where to go to modify views. You know where to go to modify your database connections. You know where to go if you want to add new controller. So that's it. But that's still not. It's fun. It's way more powerful than anything that Swath and Giraffe provides out of the box, but it's still not it's still not showing full capabilities of Saturn controllers. And full capabilities of Saturn controllers are pretty cool. So Saturn controllers, the thing you've seen before, you saw before, is showing you just simple actions. But Saturn controllers have a couple of more features. First one is subcontrollers. And subcontrollers, how to explain it well? Let's imagine that we have block engine. And we have users, which are users controller, which is returning users to your client, and it's on /users. If you want to go to particular users, you do /users/user ID, like 1, 2, 3. But this user can have some particular comments. So usually in REST, you would do something like users /123/comments, and this would return comments for this particular user. And that's exactly what subcontrollers are about. So they're about embedding controller into controller in, again, convention-based REST-ish. And if anyone really loves REST and I'm totally wrong, please don't kill me after the talk. REST-ish way. So that's one thing. The second thing, controllers are super easy to version, which is really, really powerful because our application changes over the time, and pretty often we need to maintain different versions of our APIs. And to do that, actually, we only need to have one custom keyword in the controller computation expression. We tell it what version this controller has, and it's checking against some custom header. So I know that there are a couple of approaches to versioning of your APIs. I've decided to go with header approach. So I know a lot of people are doing like V1, V2 in URLs. I've decided to go with versioning through headers. And the last thing is you can plug particular HTTP handlers, so particular lower level actions, for some of the actions. If you think about that for a moment, this is really functional way of simulating what ASP.NET MVC does with any attributes and filters actions. So usually if you have something like authorization on controller in ASP.NET MVC, you put attribute authorize on those particular method you want to authorize. Here, instead of using attributes and some magic that no one knows how worked, we actually just plugged normal functions into some of them. And yes, in this case, those are pretty simple functions, setting some HTTP header, but this can be as well authentication function that tells you, oh, for index and show, I need to authenticate user. And for different actions, I don't need to authenticate user. Well, that would be pretty stupid, but you know what I try to say. So yes, so controllers are pretty powerful. This versioning, subcontroller mechanism, and this plugging actions, I'm really, really proud of that because it's something that hasn't been explored in many other frameworks. And we are happy that FSHP community comes up with these ideas. And it's not all designed by me. I had also like many contributions from community, and I've talked with many people while building this framework. And let's go back to presentation because we are running out of time. What's next? So as I've mentioned, right now Saturn's version is 0.5, and there's a couple of things I want to do before 1.0 release. First of all, I want to implement something I call channels, and channels is abstraction over WebSockets or over any other real-time communication that you can have in your web application. Because nowadays, applications are more and more about real-time refreshes and real-time being connected all the time. Second thing is testing. Right now, and testing is both in terms of testing just framework. Again, if you know me and if you follow me on Twitter, you know that I'm not doing a lot of testing for my open source projects. But this is something that I really want to be really solid library, unlike some of my other projects like Ionite. This is like, Ionite is not important. This is really important, and I want to be really solid. So first of all, I need to do some internal testing. And secondly, I want to provide some tooling around testing for your application that would use Saturn, that enables you to test controllers, that enables you to maybe end-to-end testing or performance testing or benchmarking. So this is really a big thing for me. First thing I would love to focus on is diagnostics, and this is a bit tricky. I don't know how many of you remember, but back then in ASP.NET Web Forms time, there was this project called Glimpse. Anyone heard about Glimpse? Okay, yes, couple of you. Perfect. So Glimpse was this project that enabled you to do some real-time diagnostics while you were running application in your browser. So it would open additional, like, some small part in UI and would tell you, oh, this request took so many milliseconds, but it also would tell you, oh, this request included database call, and this database call took so much milliseconds. So it was something like developer tools for web programming in the browser, but focused on what's happening in the server, which is something really cool, and I don't know anyone doing anything like that. And I'm really sad the project died after Microsoft hired the authors, and I haven't said that. Yeah. Another thing I want to focus is deeper integration with Fable. So Fable is F# JavaScript compiler. If you don't know, it's really amazing. And Fable is the best thing that happened to F# in the last couple of years, and it's really important to be really deeply integrated with that. Actually, it's already partially done by the members of the community. So there is a project called Fable.remoting, which provides type-safe way of communicating between server and Fable. So you basically define interface, and then Fable.remoting automatically implements write paths and write roofs, both on the client and the server side. It's super awesome, and I really recommend to check it out. And the last thing I need to mention before running out of time is this thing called SafeStack. So SafeStack is initiative that we've created, me, Isaac Abraham, Stefan Forkman, and a couple of other members of community to popularize F# end-to-end web programming stack. And right now, this is like mean or LAMP stack. People love those acronyms. So safe is really nice because it suggests type safety. Yes. So it includes Saturn as a server. It includes Azure as a place where to host your code, or AWS. It works really well with A also. But don't tell Philip that I've mentioned AWS. Yeah. It includes Fable for building client applications, and in particular, it includes Elmish as this architecture of building client-side applications that we really believe that provides a lot of type safety, and it's amazing. And I think that we will learn more about it tomorrow? Friday. Yes, that would be it. I don't think we have time for questions, or we don't really do questions in this conference, but I'm around, so ask me anything. And yes, again, my name was Chris. You can find me on Twitter. You can find me on GitHub. You can find me on Instagram and 500px if you're interested more in photography than this boring programming stuff. I'm having blog on cieślak.io. I usually blog sometimes once half year. Well, but I should start blogging more often. I'm blogging about F# and open source in general. So if you're not only interested in F#, but also in some open source stuff and how open source works, feel free to check it out. I have consulting company. So if you'd be interested in any commercial support, check it out. And also, again, you maybe know me from building Ionite, but I also built it recently, a couple of months ago, a thing called Neptune. And Neptune is plugged into Visual Studio Code that provides you with super cool unit testing integration. And again, this is bringing the features of full IDE, like Visual Studio, into Visual Studio Code with F#. So you have Test Explorer that you can do like right-click debug test, and you have code lenses and all this stuff. It works amazingly. Unfortunately, it's paid product, but it has a couple of days of free trial, so please check it out. And thank you.